Hello everybody, this is using transformations to sketch graphs, and it's mainly related to 3f. Alright, now what we've got to do is to just sketch this hyperbola here. We've got to label the asymptotes and the intercepts and state the domain and range. Now I guess it's in transformations because what we can do is we know the shape of an ordinary truncus. So an ordinary truncus has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0, and has two identical arms and symmetric arms that come down like this. Now our graph is a bit like this one here, only we've transformed it. We have dilated it away from the x-axis by a factor of 2. We've shifted it 3 to the right and we've moved it 4 up. So if we were going to sketch it, we could say, righto, we really can do this based on everything we know here. It's been shifted 3 to the right, it's been shifted or translated 4 up, and it's been dilated away from the x-axis by a factor of 2. Now it's hard to draw those details, but well, I've done my best. Now the domain and range, well, let's see. I can have all real x values except for where the asymptote is here, so I can't have x equaling to 3. For the range, now let's see, I can have any number I like, but it's got to be above 4, so I could say the range will be from 4 to infinity. Let's check out the next one. Now this one, even though you might not recognize it, is actually a hyperbola. Now to do this, what we can do is we can say, alright, this line here, the fraction bar, is a divide sign. So how many times does x minus 1 go into 3x plus 2? Well, let's see. X and 3x, well, it'd have to go in 3 times. So 3 times x is 3x, and 3 times minus 1 is minus 3. When I take them away from one another, 3x take away 3x is 0, and minus is a plus. 2 plus 3 is 5. So 3x plus 2 divided by x minus 1 is equal to 3 plus 5 over x minus 1. So I can rewrite this f of x from this to be this. Now this definitely looks much more like a hyperbola. I know that it has been dilated away from the x-axis by a factor of 5, it's been moved right, and it has been moved up 3. So on the basis of the fact that I know what an ordinary hyperbola looks like, I can sketch this new one. So let's see. There's y and there's x. Now an ordinary hyperbola has vertical asymptotes, horizontal asymptotes. Now I know that it's been moved 1 right. So I'll move it across here so that my asymptote is 1. I know it's been moved up 3, so my new horizontal asymptote is there, and I know it's been dilated away from the x-axis, so it'll probably look something like this. And if I wanted to, I could work out the intercepts as well by using y-intercept x equals 0, x-intercept y equals 0. Alrighty, let's try the last one. Okay, so we have to sketch y equals negative 4 minus 3x plus 1. Alright, well the thing that helps me with this is that anything under a square root must be greater than 0. So I'll do that here. I'll take this across to the other side, so 3x must be less than or equal to 4, so x must be less than or equal to 4 over 3. Alrighty, and it's been moved 1 up and flipped around a bit. So let's see if we can figure out what this graph looks like. There's x and there's y. Okay, so it's been moved 4 over 3 to the right, and it's going down towards negative infinity. So and it's also been moved 1 up. So this point here where it starts is 4 over 3, comma 1. Now with the negative in front here, it's probably going down like this. Now I could confirm that by working out the intercepts, by making for the x-intercept, y will be equal to 0, And for the y-intercept, x would be equal to 0. Y-intercept, x equals 0. Now I'll only do this one for the moment. So that would be, in place of 0, 3 times 0 would be 0. So I'd end up with the square root of 4 plus 1. Square root of 4 is 2. 2 plus 1 is 3. Oh. Forgot my minus in front here, didn't I? So that'd be minus, minus. That'd be minus 1 there. 0, minus 1. Right, now the domain and range, now let's see. That would be from negative infinity up to 4 over 3. And the range would be from negative infinity up to 1. Alrighty, well I hope that's helped. I'll see you in class if you have any more questions.